Hello. So very glad to and honored to be invited to give this speech. So I'm Ding Sun. I'm from Scantist. We are a startup in Singapore. So we're doing the SCA software component analysis. So with Docker, every day we use Docker, but we install a lot of things in the Docker. So and all these things, one of them is open source. So bringing issues with license, with issues with vulnerabilities. So that's why we want to have the SCA to scan over the Docker. And today I will talk about two interesting topics. One is how to use SCA for Docker, and the other one is how to use Docker for SCA. So they are just like the two sides of the card. So okay, basically what is the SCA? So the SCA is a Docker and has a lot of components installed. So some packages are on OS level, some packages are for example, you can install some npm packages into a container, and also maybe some Python projects. So with all of these installation, end up with this dependency tree. So first level is your package to install. And this package may reference some other packages. So you become a tree. Maybe like models and components. So when you install these some components, you never know, and it's have issues like CVEs. So SCA is basically to scan your Docker environment to track this dependency tree. Then dependency tree from our vulnerability DB. This DB may have a lot of sources, for example, the NVD1 and also CMVD in finance. And also maybe the commercial one, you have the sleep. IBM one, so you have a loss because choices. So using vulnerability database, you're comparing with your dependency tree, then you can know what component is vulnerable and whether this issue is critical. If it's critical, you probably need to get rid of them in the early stage. And also the SCA needs to support a wide range of language and package. For example, here you need to support all of these common languages and all these OS level package packages. And also the with some figures from reference figures. So the supply chain attack become more and more popular. Nowadays, we use a lot of open source projects, and say by June of this year, there is 83 million of developers, and based on the GitHub, and also about 28 million of repository in open source, which you can directly download. And so with more open source projects, we have more vulnerabilities in our supply chain. And also we have more supply chain attacks. And for example, the typical example this year, which from last year until now, is still not our project. Then I mean it's a critical issue. And also the small type reference say by 2025, they reference to number of supply chain attacks they jump about 600 times. So SCA is quite different from other tools. For example, we have the SSD, which is very traditional one. Probably use the SonarQube, and some others. These are so-called the SSD. So these things are directly reasoning on your code, but they are very difficult to find issues in your dependency, the dependent components you are using. Also, SCA is also different from EASP. This is more like a black box testing. So SCA is so that one is a like use case diagram. To say if your application is written in house, and also whether you reference a lot of third-party libraries, then you use SCA, which is very common nowadays development process. And back to the Docker. So Docker is very popular, and based on the figures they gave on the Docker Hub, so by 2020, February 4th, the figure, then just after 1 year, the same February, you can see the number of the images. So Docker itself and also container security is a very important topic. Very reference. But here, we just talk about the first one, which is a very common one, the content image, the image security issues and the vulnerability in the image itself. There about all other things like configuration and network security, those things are that we will not cover. So regarding the SCA, how to do the SCA in a container. So each container image is basically a layered structure. So there is many layers you can install. Every time you install some package, it becomes a new layer. So the dependency property is embedded among all these layers. And if we look at the dependency itself, types, it probably can be seen this way. So you have an image, then you have a build materials, it's so-called a BOM. The BOM is all the packages you install, you use. And this one is actually inherent from your base image. For example, you use some image, and this image is reference the base one, if, for example, the Ubuntu 18 or Ubuntu 20. So inherit from this base image. Then in your own image, you have a lot of layers. On each layer, you install some package. And some are OS level package, and some are application level package. So Docker itself provide a very good tool called Docker Scan. So this tool is command line CLI, and you can use it to scan all the issues in your image. And basically, it's every time you push your image, you're triggering this Docker Scan tool to extract the BOM for you. And the BOM information will be posted to the Docker server. And we'll be comparing with some vulnerability database I showed just now. I can give you those. And once some issues will be found, like CV will be detected, will be posted back to you. We'll see this on your CLI one. So this one, the Docker scan, I just roughly give us some. So the syntax is also very simple. Just type in Docker scan your image name, and there is some options. You can output the result as a dependency tree. You can also specify the Docker file associated with this will provide answer result. Here is the example. So you can Docker scan the file. The Docker file is locally available, and this image is called Docker scan just for demo purpose. This cat, you scan and extract the BOM and post. Then you return back all the issues. So here is the critical issue, a high severity vulnerability found in the Perl package installed. And we show all the details. You can click on details. And also you can specify this command function. Bundle all the information in the tree structure. It will be more clear. And also you can specify the JSON and also the group issues, and regroup all the issues found. For example, the CV, this CV may appear multiple times. If you use this option, you can be more clear in the report. Here is an example how to use the Docker scan to find the issues in your image. For example, here I just give an example. There is an image for the Elastic Log Stash. It's very commonly used image. And this one, through the version 7, or version 7 into 7.16. Only version have the log project inside. So we just triggering all these commands. Just the Docker pull this command, Docker pull this image, right? And we just specify Docker scan with image name, specify the dependency. We're actually doing 2 steps. First step is analyzing your container, track the dependencies at the BOM. And second step is returning the external vulnerability database. So roughly will be let's see whether I have it. It will take a while for scanning, so I record on the log. Oh, sorry. Okay, so I directly jump into the location and show the issue. So it's here. It shows all the issues. Actually, the specify to the log4j. It's detect this log4j this jar inside the form, and also the critical issue is in this one. This remote code execution. Okay, so they point out the issue in this one, so you can copy this link. So as you see, it goes to the sneak. So sneak also maintain a very good vulnerability database. So this one actually it's this CVE. So if you have this issue, you definitely need to fix it because this will allow any arbitrary users outside to hijack your system. Okay, so this is the basic idea how to triggering the scanner. But in reality, the situation may be more complex. So here I show you a few corner cases which cannot be covered by the current Docker scanner. So as I just showed, in each layer, the package may comes from OS level and may also comes from application level. So in application level, you need to cover more languages. And also, there are cases that some package is modified. It's not from the public repository. For example, you use some log4j, but it's in-house built. It's not from the Maven. So this is the case. Then the third case is maybe you use some native ELF, some SO files, some dynamic linked DLLs, and these files also is on the scope of current scanning. The last case is some source files. For example, some NPM packages, the basic packages, giving source file. If you copy into your container to use it, and all these things cannot be detected. I'll show you the example. So first one is, for example, we download a package. I use a 1 to 18 as a base, and from there, I install just the Django 3.2. Okay, I install that. If you run the pip freeze, you will see this package. And this Django has a CV, which will cause in the secure injection. After that, I save this container as image called Django. Then I trigger in the same command and Docker scan. I'm trying to detect this issue. Somehow it cannot be detected. So this component cannot be captured by the current Docker scanner. I mean, for this issue. Then the second case is some modified package. Just now, when we see the log4j, because it detects a log4j jar inside location. But what I do is I find this jar, I open that log slash image. I open that, I go to the location, it's here, it's in this location. I open the jar, I remove the POM file inside. The POM file specifies the library name and the version. I just remove that meta information from the jar. Then I save it back. So the jar itself is still the same jar, but the meta file has been stripped. Then I triggering the same scan. Then this scan is so in this case, you have in-house compiled jar, you have vendor modified jar, and maybe it's malicious act jar. Someone just removed the meta information. And all these things will be currently somehow cannot be detected by the image scanner. And this situation is, say, in your Docker image, you probably will have some ELF. You use wget, you curl, and probably Docker CP, and even maybe you compile the image directly, right? Some C libraries, SO files, and I can give example. For example, I use an FFmpeg. This is some stream encoding libraries. It's an ELF files. And it has some critical CVEs. And I just Docker pull a normal Ubuntu. Then I create image. I CP this file inside. I save this image. I trigger the scan. Unfortunately, this also cannot be found. Then last case is some source files. This one I skip it. Requires a little bit steps. So With all these challenges, we find that current Docker scanner, although it's very powerful, it's very powerful, but it also has some limitations. So the current matching logic is basically name-based or hash-based. Basically, it's trying to detect some meta files inside the image or some files. For example, if they detect some jar, then you're trying to unpack it and find whether it has a POM or XML inside, then reading the name outside. And also, you're comparing against the file, the hash, against like comparing the jar against the Maven's repository and trying to detect what this jar stands for. So I think moving on, one of the things we can improve is say whether we can import like signature-based detection, let's say the AST structure and code signature. We have our lab has some paper published. So this one is to detect the jar files, or it's for Android, but it's for jar files using the AST structure. So no matter you remove your POM file or you change your file hash or your code, the basic structure is the same. The control flow is the same. So based on this, we can still accurately detect the component. And because if we use the signature, then the information you extract from the image will be much more than just a hash. So it's critical to do, probably need to consider about the data protection and transfer for signatures. So let's say, as I mentioned, the Docker scanner basically is an agent. It deploys on your local environment and extracts the dependency evidence, and then it pulls back this evidence back to the server to do the matching. And now if we want to include the signatures, and because the signature contains a lot of rich information of your own application, so posting this one outside of your environment and back to some SCA server, which will be concern for some business owner. And also the yeah, this one is we're trying to improve the Docker scanner, so we did a little bit of preliminary study. So we implement the paper we published and, with the jar. The jar just now I stripped its POM file inside, so now it doesn't have the POM file inside. But so using the AST and signature-based mechanism, we are still able to detect it accurately with this version. So further on to detect its vulnerabilities. So at least for Scantist, next year we will try to integrate our own algorithm into the current Docker scanner to improve it. Okay, but back to the day-to-day work for the best practice. I think there is some recommendation from Docker directly. So just to give the link, you can go there. Basically, you're just trying to use a clean-based image, trying to scan as early as possible. All these are good practice from DevSecOps aspects. Okay, so next topic is about how to use Docker for SDA. So just now it's SDA for Docker, now it's a Docker for SDA. So just now I think in the first talk, we talk about how to use the development environment for the Docker. I think making it very simple is also use the Docker as some sandbox. So for SDA, there is a case that the day-to-day we had the CI/CD pipelines, we use the Jenkins, all those things. But from the CI/CD, those things is the DevOps aspect. So from engineers aspect, we're trying to automate everything. We think the things can be automated. But somehow from a security expert, the things is a little bit different because they feel with so many tools, so many scanning tools, so many results, somehow we still need to aggregate them and do some manual auditing. Because all these tools cannot guarantee 100% accuracy, we still need to do some auditing to ensure your result is somehow reasonable. So that's why they suggest Other than implement all your abstract tools like SCA, SAST tools directly into your CI/CD pipeline, build another pipeline just for application security testing purpose. And all the issues we found will be aggregated to certain portal, maybe your Jira or something else, like OWASP, some tools, so-called abstract orchestration. Okay, so from here you will concentrate and aggregate all the issues you found. So in reality, that we see if the security team want to build such application pipeline, they encounter some issues. For example, they don't have access to the development CI/CD pipeline because usually in an organization, the security team and development team is still two teams. So they don't have access to the development team's CI/CD pipeline. They also don't want to interfere with the normal development, and they also don't deal with the environment dependency. And nowadays, the application they need to install a lot of stuff, and they don't want to bother into what is maintaining what it seems. So we have a client in China, and they surprisingly they have a very large number of repository that they need to manage. And with a long project, they found that since they have like more than 10K reports, they've been given a command to dig out all the log4j within 2 days. So they cannot sleep. They stay in the office trying to do that. So after that, we find out, although the report is so many, but somehow the environment is somehow limited, less than 100. For example, and also all these environment is strongly associated with the application itself. For example, all the Java application environment is same, all using JDK 11 plus Maven for this point. So in this case, we can Docker quickly have the toolbox and help users to compile all these environments or prepare them like a sandbox. So when we want to triggering the SCA scan, we can just call these, pull out all these into sandbox. Also, there is also two more small use differences. Number one is the so-called post-built SCA. So in this case, with some scan requests have been posted to your, maybe it's an abstract pipeline to this pipeline. Then this one will pull out the sandbox within Docker, then build your application inside, then post this dependency to your SCA service for matching. In another case is the so-called pre-built. So this one you say the scan request is directly sent to the SCA service without any compilation. So this SCA service will help you to run CI/CD agent, run this sandbox inside the SCA service. Then build your code, build your application, then extract the dependencies. Okay, then for us ourselves, is we just spin off in NTU from NTU. And also we have a few points and taking feedback in China and also some companies in China. And also we work closely with Power. And also we are hosting some DevSecOps calls. So we will have some issues with local partners regarding about the DevSecOps topics. Have some training. And also we are working with open source security to have some community events. Yeah. So basically that's all. Yeah. You can approach me for any questions and solutions.